Recently, I was studying the Feynman lectures on physics volume 3 on quantum mechanics and I encountered something amazing. And I wished if I could share this information with all of you. And voila, here I am. We have studied earlier that the nuclear forces are the same between the neutron and a proton, between proton and the neutron and the neutron. Why is it then that a proton and a neutron can stick together to make a deuterium nucleus, whereas there is no nucleus with just two protons or with just two neutrons? The deuteron is a matter of fact bound by an energy of 2.2 million electron volts, yet there is no corresponding binding between a pair of protons to make an isotope of helium with atomic weight 2. Such nuclei do not exist. The combination of two protons does not make a bound state. The answer is a result of two effects. First, the exclusion principle, and the second, the fact that the nuclear forces are somewhat sensitive to the direction of spin. The force between a neutron and a proton is attractive and somewhat stronger when the spins are parallel than when they are opposite. It happens that these forces are just different enough that a deuteron can only be made if the neutron and proton have spins parallel. When their spins are opposite, the direction is not quite strong enough to bind them together. Since the spins of the neutron and proton are each 1/2 and are in the same direction, the deuteron has a spin of 1. We know, however, that two protons are not allowed to sit on top of each other if their spins are parallel. If it were not for the exclusion principle, two protons would be bound, but since they cannot exist at the same place with the same spin directions, the helium-2 nucleus does not exist. The protons could come together with their spins opposite, but then there is not enough binding to make a stable nucleus, because the nuclear force for opposite spins is too weak to bind a pair of nucleons. The attractive force between neutrons and protons of opposite spins can be seen by scattering experiments. Similar scattering experiments with two protons with parallel spins show that there is corresponding attraction. So it is the exclusion principle that helps explain why deuterium can exist when helium-2 cannot. I hope you liked the video, and if this was something new for you, then please share it with someone else as well. I'll meet you again in some other tale of physics at Physics Tales.